Hi guys, Ms. Delitto here. Today we're going to take a look at combining like terms. We're going to take a look at this first expression, 3x minus 1 minus 5x plus 3, and I'm going to show you how to both represent this using algebra tiles as well as procedurally simplify this expression. So the whole point of simplifying is to make an expression easier for us to work with. So we want to combine any like terms. A reminder, like terms are terms that share the exact same variable. If we were to use algebra tiles to represent this expression, 3x, which is the first term that I see here, is going to be represented by 3 green rectangular rods. That's showing positive 3x. The second term that I see in this expression is minus 1 or negative 1. And I'm going to represent this using a small red square. The next term that I see is negative 5x, and I'm going to circle this in blue because this shares the exact same variable as 3x. I would represent negative 5x by using 1, 2, 3, 4, 5 red rectangles. And the last term that I see here that I'm going to circle in red is positive 3. And even though 3 and negative 1 do not share the exact same variable, they are both constants, and we know we can combine negative 1 and 3. That's going to be represented now with 3 yellow squares. Since we're combining the things that are like, I'm going to move all these rectangular rods so they're all in a group together, and all of these little squares so they're in a group together. We know back from integers that a positive and a negative cancel each other out or make what we call a zero pair. So I'm going to go ahead and make any zero pairs that I see here. So I have 1 negative square and 1 positive square. Because these are the same value, I know I can cancel those out. I cannot make any more zero pairs with my squares, and I cannot use one of these positives to cancel out a negative rod because they're not the same exact value. I'm going to do the same thing now with my rectangular rods. I am now left with 2 negative x's, or negative 2x, and 2 positive squares, or plus 2. I can think of this procedurally by taking a look at my coefficients with the variables, so 3 and negative 5, and combining those. I know 3 combined with negative 5 is negative 2, and since I'm looking at x's, that would be negative 2x. And I know that negative 1 combined with positive 3 would give me positive 2. The next example that we're going to look at is going to be a little bit different. So we're going to take a look at 2x to the second power minus 2x plus x to the second power minus 3x. So again, our goal is to simplify this expression by combining any like terms or terms that share the exact same variable. What's tricky about this is that we know that x and x in both of these terms are the same exact variable, but they're represented by very different things. The first term that I see is 2x to the second power. We know in our algebra tiles, x to the second power is going to be represented by one big square, and since I have 2x to the second power, I'm going to use 2 big squares to represent that. The next term I see is negative 2x, which we'll use 2 red rods to represent, a positive x squared, so we'll use 1 big blue square, and a negative 3x. So we'll use 1, 2, 3 red rods. So similar to what I did before, I'm going to go ahead and group all of my big blue squares together and group all my rods together. And I'm looking here and I don't see any zero pairs. I do not have a positive and negative rod to cancel out, and I do not have a positive and negative x squared to cancel out. Because these are not the same exact value, I cannot combine them. So I am now left with 1, 2, 3 x to the second power, and 1, 2, 3, 4, 5 negative red rods, or negative 5x, or minus 5x. Similarly, I can look at this procedurally and think to myself, well, if I have 2x squareds and my invisible coefficient here of 1, 2 plus 1 is 3. I have 3x squareds. I have negative 2 combined with negative 3, which is negative 5, to give me negative 5x, or 3x squared minus 5x. Now we'll take a look how to represent this procedurally without those algebra tiles. So we're going to take a look at the example 4a minus 2b plus b minus 2a. The first thing that I'm going to do here is I'm going to identify the first term in my expression, which I see is 4a. I'm going to circle that in red. And now I'm going to look to see, is there a term that has the exact same variable or has a as a variable? And I see this term here does. When I circle this, I want to make sure that I'm including the sign in front of it, because that sign is going to tell us if this term is positive or negative. I'm going to do the same thing for the next like terms that I see. So I see negative 2b, again including the sign in front, and a positive b. Now I'm going to combine my like terms. Anything circled in red can be combined, anything circled in green can be combined, but a green and a red cannot be combined with each other because they do not share the exact same variable. When you combine these like terms, it's very important to pay attention to those signs. That's where most of the mistakes are made. So I'm looking at positive 4a and negative 2a. I like to visualize the algebra tiles without even using them and think I'm going to have 4 green rods and 2 red rods. Once I make my 0 pairs, I'm going to have 2 green rods, or positive 2, left over. Same thing I'm going to think about here. I have negative 2b and positive b, or positive 1b. So I'd have 2 red rods and 1 green rod. So I'd be left with 1 red rod, or minus b, or minus 1b. We can think about the same way with our coefficients. So we have 4 combined with negative 2, which is 2, and negative 2 combined with positive 1, which is negative 1. Let's do one more example. 6m squared plus 3m minus 2m squared minus 5m. So the first thing I'm going to do here is identify my pairs of like terms. So I know if I'm visualizing with algebra tiles that I would represent these terms with m squared very differently than I would these terms with just m. So 6m to the second power, I also see an m to the second power, negative 2m to the second power, making sure that I'm including the sign in front, which shows that it's a negative term. I'm going to do the same thing with my other terms that share the exact same variable. So positive 3m and negative 5m. And notice now how everything in my expression is circled. There's nothing left out. Now we'll combine our reds. So if I have 6m squared and take away 2m squared, I'm left with 4m squared. If I combine my positive 3m and my negative 5m, or take away 5m, I'm left with negative 2m. Just kidding. One more example. 4r plus 2q plus 3rq minus r. What's tricky about these examples are that even though 3RQ shares the exact same variable as 4R and 2Q, this is not actually the same variable. In this case, our like terms would be 4R and negative R, 2Q, and positive 3RQ. We can think about this in terms of different shapes. So let's say that R is represented by a square and Q is represented by a triangle. That means that RQ would be represented by a little house. The triangle is not exactly the same as the house, and the R is not the exact same thing as the house. Therefore, squares can't be grouped with the house, and triangles cannot be grouped with the house. To simplify this expression, we're going to combine those things we can group together. So 4R minus R, or minus 1R, leaves us with 3R. And because I cannot combine 2Q or 3RQ with anything else, I'm just simply going to write that into my simplified expression. Hopefully you found this video helpful, and if not, we can check in class tomorrow. Good luck.